All right, welcome. Today we are diving deep into the world of econometrics. And look, I know what you might be thinking. Numbers, equations, but trust me, this is not just some dry academic subject. It's actually a battleground for ideas. We're talking about a huge disagreement over the most fundamental question of all. How do we find truth in the incredibly complex world of economics? So, let's get right into it.
I mean, this is the big one, right? How do we find truth? The economy isn't some neat little lab where you can control all the variables. No way. It's this messy, sprawling, complex system with billions of people making trillions of decisions every single day. So when we need to know if a policy will actually work, how can we be sure? This single challenge has basically split the field of economics into two rival camps.
So on one side, you've got the theorists. These guys believe you have to start with a big, overarching theory of human behavior, a top-down deductive approach. Think of it like starting with a detailed blueprint for how the world should work, and then you check to see if reality matches up. And then, on the other side, you have the practical men. They say, whoa, hold on, start with the data. This is a bottom-up, inductive approach. You build your understanding from the ground up, piece by piece, based on what you can actually observe.
Okay, so let's dig into the practical men's case first. You can really think of them as detectives. They're out there sifting through mountains of real-world data, looking for clues, trying to solve these massive economic puzzles. Their whole goal is to find those rare moments where the messy world suddenly offers up a nice, clean answer. And their absolute favorite tool for the job is something called a natural experiment. This is when the real world, just by pure chance, happens to create a situation that looks almost exactly like a controlled scientific experiment. It's their secret weapon for finding a clear cause and effect relationship without needing a lab. Let's look at a really brilliant example of this in action. So here's a question you've probably wondered about yourself. Do smaller class sizes actually help kids learn better? It seems like it should be simple, right? But answering it for real is an incredibly tricky puzzle, and it's exactly the kind of challenge the practical men just love to tackle. And their solution? Well, it's a total masterclass in their approach. Okay, so here's the core of the problem. You can't just compare the test scores of kids in small classes to kids in big ones. Why not? Well, because parents who are really involved in their kids' education are often the same parents who are more likely to seek out and maybe afford schools with smaller classes. So if those kids do better, is it because of the class size, or is it because of their parents' influence? The data is all tangled up, or as an economist would say, it's confounded.
So how in the world do you untangle that mess? Well, two econometricians, Joshua Angrist and Victor Lavie, found this unbelievably clever solution in the most unexpected place you can imagine, a rule from a 12th century rabbi named Maimonides. And believe it or not, this ancient rule was actually being used to set class sizes in modern Israeli schools. And this, right here, is the aha moment. The rule is super simple. You cannot have more than 40 students in a single class. So if a school has exactly 40 fifth graders, they get one big class. But if that school has 41 fifth graders, they are forced by the rule to split them into two small classes of about 20 kids each. Think about that. That one extra student creates this massive, and this is the crucial part, totally random change in class size that has absolutely nothing to do with parents or money or anything else. So when you plot this out on a graph, you see this really unique sawtooth pattern in the class sizes, right around the 40, 80, and 120 student marks. This pattern is like a fingerprint. It's proof that this arbitrary rule, and not some other hidden factor, is what's driving the change. It allows them to finally isolate the effect, and their finding was clear. Yes, smaller classes really did lead to better test scores. It's just a brilliant piece of data detective work. But just as the practical men were taking their victory lap, the theorists stepped in and said, whoa, not so fast. They argue that even these super clever data tricks can be dangerously misleading if you don't first start with a solid theory of how people actually behave. And their whole critique really hinges on this subtle but absolutely crucial distinction between two words, external and exogenous. So a rule like Maimonides is external. It comes from outside the system of parents and schools. But is it truly exogenous? That's the real question. For it to be exogenous, it has to be completely immune to people's clever reactions and strategies. And the theorists argue that in the real world, almost nothing is. I mean, think about it.
Take Maimonides' rule again. A theorist would ask, what if savvy parents figure out the system? Couldn't they maybe move their kid to a school district they predict is going to have 41 students, just to guarantee that smaller class size? And poof, suddenly your beautiful randomness is gone. The same problem pops up with other famous natural experiments. Like the Vietnam draft lottery. Could employers have checked a young man's lottery number and decided, you know what, I'm not going to invest in training this guy? The data trick starts to fall apart once you remember that people are smart and they react to things.
So all of this leads to the theorist's core demand. Before you even think about touching the data, you have to start with a rigorous model of how you expect rational people to act and react. You have to deduce your predictions from general principles first. Otherwise, they'd say, you're just finding meaningless patterns in the noise, and you could end up recommending policies that totally backfire.
Now, here's what makes this whole thing so fascinating. This debate, it is not new, not by a long shot. This exact same fight, theory first versus data first, has been raging in economics for over 150 years. It just keeps popping up with different names and different people.
I mean, you can trace it all the way back to the philosopher-economist John Stuart Mill in the 1840s. Then in the early 1900s, there was this huge German-Austrian battle of methods. The data-first side lost. Fast forward to the 1940s, a new debate explodes called measurement without theory. And guess what? The data-first camp lost again. History shows this pretty clear pattern. Every time this battle gets fought, the theory-first side seems to eventually come out on top. Which, of course, brings us to today. The modern practical men, the ones championing all these natural experiments, they claim their methods have sparked a credibility revolution. They say they've made economic research more believable, more useful for policymakers than it has ever been before. But the big question is, have they really broken that historical cycle?
So this is pretty much the standoff today. You've got the practical men saying, look at our clever, data-driven results. This is credible science that can actually inform real policy. But then the theorists push right back, warning that without a strong theoretical foundation, all those findings might just be built on sand. For them, true credibility only comes from a deep understanding of the economic principles at play.
And based on this whole historical pattern, the author of the article we're exploring here makes a pretty bold prediction. They're willing to bet that, just like every other time, the theorists are going to win this round too. And then, in about 50 years or so, a new, energetic, data-first movement will rise up and challenge them all over again, just continuing this fascinating cycle.
And that leaves us with the ultimate question, one that goes way beyond just economics. When we have to make huge decisions about education, healthcare, the climate, policies that are going to affect millions of lives, what should we put our trust in? Should we trust the beautiful, elegant, top-down logic of a grand theory? Or should we trust the messy, clever, bottom-up evidence from the data? There's no easy answer. And that very tension is what makes the quiet world of econometrics so incredibly important.